let's take a look at this example. We have to find Z total. Okay, in order to find Z total, we have to find first the impedance of capacitor C1 and impedance of capacitor C2. So start always with the formulas. So I have Z C1 is equal 1 over 2 pi F C1. Okay, so I have 1 divided by, open parenthesis, 2 pi times the frequency, which is equal 2 megahertz. 2 megahertz times C1, which is equal 1 nanofarad. Okay, this is equal. So I can write that Z C1 is equal 1 divided by, open parenthesis, I have 2 pi times 2 exponent 6 times 1 exponent 9 negative, close parenthesis. This is equal 79.57 ohms. And because we are talking about the impedance of the capacitor, you're supposed to add angle negative 90 degrees. Or you can write that this is equal negative J 79.57 ohms. Okay, either answer is correct. Next, we're supposed to find ZC2. ZC2, okay, I'm going to write again. The formula is equal to 2 pi FC2, and this is equal 1 divided by, open parenthesis, 2 pi times the frequency 2 megahertz, 2 megahertz times the capacitance 2.2 nanofarads. Okay, so I have ZC2 is equal 1 divided by, open parenthesis, 2 pi times 2 exponent 6 times 2.2 exponent 9 negative, close parenthesis. This is equal 36.17 ohms and angle of negative 90 degrees. Or you can write that this is equal negative J 36.17 ohms. Okay, either answer is correct. Next, in order to find Z total, I'm supposed to find the impedance of this branch and impedance of this branch. I'm going to call this impedance of these two components together Z1, and impedance of these two components together I'm going to call Z2. So, because these two components are connected in series and these two components are connected in series, I'm going to simply add R1 to ZC1 and R2 to ZC2. So Z1 is equal R1 plus ZC1, which is equal, R1 is 33 ohms plus ZC1 we found is equal 79.57 ohms and angle of negative 90 degrees. So I have 79.57 ohms and angle of negative 90 degrees. This is equal, use the calculator, we have 33 ohms, so I have 33 plus 79.57 and angle of 90 negative. This is equal 86.14 ohms and angle of negative 67.47 degrees. Okay, so this is the impedance of my first branch. Next, I'm supposed to find Z2. Z2 is R2 plus ZC2, which is equal, R2 is 47 ohms and C2, impedance of capacitor C2 is equal 36.17 ohms. Okay, so I have R2 is 47 ohms plus 36.17 ohms and angle of negative 90 degrees. This is equal, so I have 47 ohms, I have 47 ohms plus 36.17 and angle of negative 90. This is equal 59.3 ohms and angle of negative 37.58 degrees. Okay, so this is the impedance of my second branch. Please notice that these two branches are in parallel. So I can redraw this circuit to make this network looking a little bit simpler. So I have a voltage source and I have my Z1 and I have Z2. Now you can see very clear that these two impedances are in parallel. So in order to find the total impedance of these two, I'm supposed to use the formula for the parallel circuit, okay? So I have Z total in this case is equal to Z1 times Z2 over Z1 plus Z2, okay? So this is equal, let me write this down over here. So I have Z total is equal Z1, which is equal 86.14 ohms and angle of negative 67.47 degrees times Z2, which is equal 59.3 ohms and angle of negative 37.58 degrees over, open parenthesis, I have 86.14 ohms and angle of negative 67.47 degrees plus 59.3 ohms and angle of negative 37.58 degrees. This is equal. So I have Z total is equal. Now we are going to use the calculator. So we have 86.14 angle of 67.47 negative times 59.3 an angle of 37.58 negative equals, divide by open parenthesis, 86.14 an angle of 67.47 negative plus 59.3 an angle of 37.58 negative, close parenthesis. This is equal 36.3 ohms. So I have Z total is equal 36.3 ohms and angle of negative 49.7 degrees. Negative 49.7 degrees. So this is my Z total. Next, the problem is asking me to find the current which goes through the branch Z2. Okay, so I simply have to realize that this is parallel circuit and the voltage across impedance Z2 is my voltage source. So let me write this down over here. I Z2 is equal voltage source over Z2 because this is the parallel circuit. One more time, voltage source is going to appear across impedance Z2. That's why I'm going to use simply Ohm's law. So voltage source is equal 2 volts RMS divided by Z2. We found that Z2 is equal 59.3 ohms and angle of negative 37.58 degrees. Okay, so this is equal. I'm going to write this down over here. I Z2 is equal. So I have 2 divided by 59.3 and angle of 37.58 negative. This is equal 33.72 ohms. So I have 33.72 ohms and angle of 37.58. 37.58 degrees. Okay, so this is the current which will go through impedance Z2. Now please notice that in impedance Z2 we have capacitor C2. Why I'm mentioning capacitor C2? Because we have to find also the current which goes through this capacitor. So please realize that the current IZ2, okay, is equal to the current which goes through resistor R2, and this is also current which will go through the capacitor C2. That's why I'm going to write that my IZ2 is also equal to IR2, and this is also equal to IC2. Okay, so far we've found Z total, we've found IZ2, and we've found IC2. Next, we can find the current which goes through the resistor R1. Please notice that the current which goes through resistor R1 is nothing else than the current which goes through the entire impedance. Okay, so again, we are going to use Ohm's law, so I'm going to write that I Z1 is equal to I R1. This is also equal to I C1, and this is equal voltage source over Z1, where voltage source is equal 2 volts divided by, we have Z1 which is equal 86.14 ohms, okay, and angle of negative 67.47 degrees. Okay, so this is equal, use the calculator, so I have 2 divided by 86.14 and angle of 67.47 negative. This is equal 23.21 milliamps and angle of 67.47 degrees. Okay, so this is my current which goes through resistor R1. Next, we're supposed to find the voltage across capacitor C1. So if I have the current which goes through this capacitor and I know the impedance of this capacitor, I'm going to use Ohm's law to find the voltage across this capacitor. So this is my IC1 also. Okay, keep in mind that IR1 is equal to IC1. So if I want to find VC1, I simply multiply IC1 times ZC1. And we found that IC1 is equal 23.21 milliamps and angle of 67.47 degrees times ZC1, where ZC1 was equal 79.57 ohms, an angle of negative 90 degrees. So I have 79.57 ohms and angle of negative 90 degrees. So I have VC1 is equal 23.21 exponent 3 negative angle of 67.47 times 79.57 an angle of 90 negative. This is equal 1.84 volts. Okay, so I have 1.84 volts, and don't forget about the angle, second function exponent. This is my angle, negative 22.53 degrees. Okay, so we found all missing quantities, so we can say that the problem is solved.